We're going to look at 1.4, which is angles, and also the angle addition postulate. Okay, so we got to talk a little bit about angles. All right, an angle is formed by two rays with a common endpoint. So what does that mean? Okay, a ray is part of a line that starts at an endpoint and goes forever in one direction. Okay, so these are both rays. So here are two rays with a common endpoint. That common endpoint is B, and it is called the vertex. The rays are called the sides of the angle, and we name an angle using three letters. The middle letter has to represent the vertex. So in this picture, I could say angle ABC or angle CBA, but B has to be in the middle because it's the vertex. If there's only one angle in the picture, then you can just use a single letter, like angle B, okay, for this picture. Sometimes we talk about how big the measure of an angle is, and in that case, we'll use an M in front of it. Measure of angle ABC is 60 degrees. Okay? So there are four different types of angles. There is an acute angle, which is less than 90 degrees. There is an obtuse angle, which is greater than 90 degrees. There is a right angle, which is equal to 90 degrees. And this one here that doesn't look like an angle at all, the rays are going in opposite directions. That is called a straight angle. And that is equal to 180 degrees. Okay, so we're going to look at example 1. In this picture, the vertex is right here. Okay, so the name of that is K. The sides of the angles are the rays that have the common endpoint. So those are ray KL and ray KJ. Now remember, in geometry, our things need hats, and our hats should look like the thing that it is. So the ray hat looks like the picture of a ray. There are three ways to name this angle. We have angle LKM. Sorry, not M. It's not M at all. It's J. Angle JKL. And then, because there's only one angle here, I can say angle K. This angle is bigger than 90, so it is obtuse. So we can look at example 2 again. Actually, I'm going to have you guys do those on your own and raise your hand. I'll come around and check it. Down here, we have congruent angles. We have if the measures are equal, then the angles are congruent. So the way that we write this is angle A is congruent to angle B. Congruent, remember, has a hat on the equal sign. And the way that we can write that in my picture is I can put these curvy things on there to show that they are congruent. Okay, so let's look at some more vocabulary. This first part is just vocabulary here. An angle bisector is a ray that divides an angle into two equal angles. Okay, so you can see in this picture, we have BD, ray BD, and it divides this ABC into two equal parts. I know that they're equal because of the congruence marks here. So the way that I would write that is in this picture, ray BD is an angle bisector. Therefore, angle ABD is congruent to angle DBC. All right, let's talk about what it means to be perpendicular. Two lines that intersect at a right angle are said to be perpendicular. And the symbol, we can see this in our picture. We use a right angle block in our picture to show that those are perpendicular, but the way that we might write it in writing is an upside down T. So that means, like, if I look at this picture on the right-hand side, that line L is perpendicular to line M. Now, sometimes if you have something that's perpendicular and it divides it into two equal parts, That's called a perpendicular bisector. So a perpendicular bisector is a line, segment, or ray perpendicular to a segment at its midpoint. Okay, because this spot that's cut right through here, that has, if it's halfway, that means it has to be a midpoint. So in this picture, segment or line, you could write it either way, LM, is the perpendicular bisector to segment PQ. So we have some options in terms of what kind of hat to use on LM, because we could think of it as segment LM or line LM. But when we talk about PQ, it has to be a segment because it stops at P and Q. All right, so let's look at example 3. First, we're going to find another name for CBF. So there's more than one angle there, so all I can do is go in the reverse order, angle FBC. Okay, then I'm trying to find the sides of EBD. So here's BD and BE. And those are rays, so I have to put ray over top. BE and BD. Now, I didn't kind of talk about this before, but do you see how this B is the end point, and that is in the right place underneath my ray picture? Okay, there's no arrow over B because there's no arrow here at that B. All right, now let's classify A, B, C. This is a straight angle. An example of an obtuse angle in this picture, there are several here, but maybe I'll pick ABF. Angle ABF. And two congruent angles. Notice here I have two with congruent marks, so those are my congruent angles. So EBA and CBF. Angle EBA and angle CBF. And then a perpendicular bisector. Do you see how BD here intersects at the midpoint? I know it's a midpoint because of these congruent marks. So I could say that the perpendicular bisector is BD, and I could either use a ray hat or a segment hat, either one. I'm going to do number 4 as well because this is a kind of a crazy looking picture. The vertex of angle 2 is T. The sides of angle 4 are TW and TZ, ray TW and ray TZ. Another name for angle 3 is angle UTZ. I can't just use T because there's too many angles happening at T. Another name for angle 1 is angle YTX. Classify YTW. Okay, it is a right angle. Classify YTU, that's bigger than 90, so that's obtuse. Classify XTU, that's less than 90, it's acute. Classify WTX, ooh, that's straight. Name two perpendicular lines. Here's the right angle, so we can have WX and YZ. WX and YZ. And an angle bisector, we can see that we have these two congruent marks, so TU is our angle bisector. We can call that ray TU. All right, so lots of vocabulary. Now, let's move on to angle addition postulate. If you have a ray that divides a big angle into two equal parts, then those two angles will add up to make the whole angle. So the way that we would write it in this picture is angle ABD plus angle DBC equals angle ABC. The two smaller parts add up to make the big one. So in this example, if I have ABD is 48 and DBC is 78, then I'm going to add those. 48 plus 78 is 126. Okay? And number 2, if this part is 74 and the whole thing is 119, what's this missing part here? I can subtract. 119 minus 74 equals 45 degrees. So now in this one, I have some more things happening. I still have PQR. It tells me, and I'm going to write this on here, that the whole PQR is 141. So this angle addition postulate says that this part plus this part is going to equal the whole thing. So I'm going to write that. 13x plus 4 plus 10x minus 1 equals 141. Okay, so we can combine our x's to make 23x, combine our constants to make plus 3 equals 141, and I have a two-step where I can solve. Subtract 3, 23x equals 138, divide by 23, and x equals 6. Okay, we also have to find PQS. Okay, so here's the PQS. So now I'm substituting that in. 13 times 6 plus 4. Okay, that's 78 plus 4, which is 82. And then here, 10 times 6 minus 1, that's 60 minus 1, which is 59. And I could add those two together and see that also does equal 141. So that's good. Okay, number 4, it's really important to label your picture if possible. It says DEF, the whole thing, is 7x plus 4. It says that DEG is 5x plus 1, and GEF is 23. So I've labeled my picture. Now I can see that the two smaller parts have to equal the whole thing. So I'm going to add them up. 5x plus 1 plus 23 equals 7x plus 4. So this is 5x plus 24 equals 7x plus 4. Subtract 5x from both sides. 24 equals 2x plus 4. Subtract 4. 20 equals 2x. Divide by 2. X equals 10. So now let's plug in what we didn't know. DEG, that's 5 times 10 plus 1. That's going to be 51. And for DEF, that's 7 times 10 plus 4, which is 74. Okay, I want you to go ahead and try number 5 on your own. Raise your hand if you get stuck or when you get done so I can check your work. You can move on. Okay, number 6, it says that DEF is a straight angle. It says that DEG is 23x minus 3, and GEF is 12x plus 8. Really important to label your picture. Now, if you remember back from the beginning of the lesson, we talked about a straight angle was 180 degrees. So we're going to take these two parts and we're going to set them equal to 180. So 23 plus 12 is 35x plus negative 3 plus 5 is, plus 8 is 5 equals 180. Subtract 5. 35x equals 175. And when you divide by 35, you get x equals 5. Okay, so now we're going to find these missing parts here. DEF, we know from the beginning we said that that was 180. DEF was the straight angle. I can find the other ones by doing 23 times 5 minus 3. And that gives me 112. And then 12 times 5 plus 8. 60 plus 8 is 68. Okay. Number 7. It says TUW is 5x plus 3. So I'm labeling my picture. I don't know what it's asking me yet, but I am labeling my picture. WUV is 10x minus 5. It says the whole thing, TUV, is 17x minus 16. So, again, the angle addition postulate says that this part plus this part equals the whole thing. So that's what I'm going to do. 5x plus 3 plus 10x minus 5 equals 17x minus 16. So I'm going to combine some like terms. 15x minus 2 equals 17x minus 16. So I'm going to subtract 15x. Negative 2 equals 2x minus 16. Add 16. 14 equals 2x. When I divide by 2, I get x equals 7. So now I can plug in all that 7 into all of my x's. Okay, so to find t uw, 5 times 7 is 35 plus 3 is 38. And then 10 times 7 minus 5, that's 70 minus 5 is 65. And then I have a choice. I can either plug this in here, or I can just add 38 plus 65. Either way, I'll get 103. All right, normally I would let you try the last one on your own, but number 8 uses some language we need to talk about. Here, we're going to find ECD that's 6 less than 5 times BEE, BCE, and then BCD is 162. So let's label that. We've got the whole thing is 162. And it says that this bigger one is 6 less than 5 times BCE. So what I'm going to do is I'm going to let BCE be my x. And so I'm going to draw that. I don't know what it is, so I'm going to call it x. Then ECD is 6 less than 5 times that. So the way that I write 5 times x is 5x. And the way that I write 6 less than 5 times is subtract 6. So now I can say I've got 2 parts that I can add together to make the whole thing. 5x minus 6 plus another x equals 162. So I can solve that. I'm going to add 6. 6x equals 168. Divide by 6 so that x equals 28. And remember how I let my BCE equal x? So BCE is 28. And then I can plug in 5 times 28 minus 6. I can do that in my calculator and get 134. Okay, so on number 9, we're going to use the information given. It says that ABF is 6x plus 26. EBF is 2x minus 9. And ABE is 11x minus 31. Okay, so again, the 2 parts are going to add up to make the whole thing. So I'm going to set it up and then you're going to solve it. 6x plus 26 plus 2x minus 9 equals 11x minus 31. Go ahead and solve for x. Raise your hand when you're done. I'll come around and check it. And then it does say find ABF. So after you find x, you're going to put it right here to find ABF. Okay, and then for the last one, I'm going to erase what I have here. It says that BD bisects CBE. So the first thing I'm going to do is I'm going to put in those congruent marks to show that those are equal. Then it says that BC is perpendicular to BA. So I'm going to make a right angle block to show that that's 90 degrees. Then it says that CBD is 3x plus 25. And DBE is 7x minus 19. And I'm supposed to find ABD. Okay, so the first thing I'm going to do is I'm going to use this information about bisecting to say that those 2 parts are equal. So 3x plus 25 equals 7x minus 19. So I'm going to subtract 3x from both sides and get 25 equals 4x minus 19. I'm going to add 19 to both sides. This will be 4x equals 44. And And when I divide by 4, I get x equals 11. So I'm trying to find ABD. ABD. So I'm going to put my x that I just found in place of that x. 3 times 4 plus 25. That's 12 plus 25, which is 37. Okay? So ABD was this 90-degree angle plus the 37 that I just found. That's what I'm going to do. 90 plus 37 equals oh, I made a mistake. Do you see that? Here I had x equals 11, and then I plugged in 4. I don't know why I did that. Okay, so I'm going to erase this 4 right here, and I'm going to put an 11 there. And I'm going to get rid of this. Okay. So 33 plus 25 is 58. So then I'm going to take that 90 degrees, I'm going to add 58, and I'm going to get 148. And that's my final answer. Raise your hand, show me what you've done, so I can get you your homework.